Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we have topic that is precision. First of all, we talk about the meaning of precision. The meaning of precision is precision mean reliable, precision mean trustable, precision mean consistency. Okay, these are the meaning of precision. Consistency, reliable, or trustable. Okay, these are the meanings of precision. First, let us take an example. The example of precision that suppose if we talk about the weather. If we talk about the weather, look at the temperature of Peshawar. At the morning, the temperature of Peshawar is suppose 20 degrees centigrade. At the noon, the temperature of Peshawar is 50 degrees centigrade, and at the evening, the temperature of the Peshawar is 15 degrees centigrade. Okay, so look at here. These are much larger variations among these temperatures. So it means that the temperature of the Peshawar is not reliable. It means that the temperature of the Peshawar is not consistent. Okay, so it means that the precision of this temperature is less. Okay, now let us take an example of Russia. If we look to the temperature of the Russia is minus 4 degrees centigrade at the morning, minus 2 degrees centigrade at the noon, and minus 3 degrees centigrade at the evening. Okay, so look at here. These temperatures are more close to each other. These temperatures are more consistent. So it means that the temperature of the Russia is reliable. It means that the temperature of the Russia is consistent to one another. So it means that the temperature of the Russia is having high precision. So precision means if a reading is consistent, if a reading is more close, if a reading is reliable, so that is called precision. That is the meaning of precision. Let us define the precision as the closeness of measured values with one another is called precision. The closeness of measured values with one another, that is called precision. Suppose a student A measure a reading of 1.3 and he repeats this experiment again and he found the reading is 1.4. So look at here. These readings are more close to each other. If these readings are close, so it means that this reading has high precision. Suppose another person B want to calculate the value of G. Okay, the value of G, he found that the value of G is 8.7 meter per second square, and he repeated this experiment again and he found that the reading of G is 9.7 meter per second square. So look at here. These readings are not consistent. This reading has a large difference between one another. So it means that these readings are not closed. If they are not closed, it means that this precision is very low. So precision means the readings are very close to one another. The precision means the readings are more consistent to one another. So that is called high precision. Okay, remember precision is inversely proportional to least count. Precision is inversely proportional to least count. Okay, actually this relation is not exist in our books, but literally the meaning is that the least count is small, the precision will be high. So precision and least count are inversely proportional to one another. For example, if we have reading A 1.2 centimeter, reading B 2.35 centimeter, reading C 7.531 centimeter. Okay, so look at these three readings. How we can say that the precision is high or low? So look at the least count. Its least count is 0.1. Look at the least count of this reading. The least count here is 0.01, and here look at the least count. The least count is 0.001. Okay, the least count is 0.001. So the least count of this number is very small. So if the least count is very small, so it means that the precision is very high. So precision is inversely proportional to least count. Okay. So least count and precision has relation inverse. For For example, if we have a dot and we have to aim this dot by arrows. Okay, suppose a shooter comes and he shoot 3 arrows on this dot. So for example, 1 shoo, another 2 shoo, another 3 shoo. So 3 arrows hit the dot here, here and here. So look at these 3 shots. Okay, so these 3 shots are very far from one another. Far from one another. Far from one another means these are not close to one another. If they are not close, so it means that the precision of this shooter is very low. Okay, another person comes and he shoot it for 3 times, and we found one shot is hit here, another is here, another is here. So look at here, these 3 shots are very close to one another. If these 3 shots are close to one another, it means that the precision of this person is very high. This person is a reliable shooter because the reading or the arrows are very close to each other. If they are close to each other, so it means that its precision is very high. Okay, so precision and accuracy both are different. Precision only means that the readings are very close to one another. Okay, come towards accuracy. What is meant by accuracy? Okay, accuracy means correctness. Accuracy means exactness. Okay, so how we can define it? The closeness of measured value, the closeness of measured value to the actual value, the closeness of measured value to the actual value is called accuracy. Okay. What is the difference between among precision and accuracy? Precision is the closeness of measured value with one another, and accuracy is the closeness of measured value with the actual value. Okay, measured value with the actual value. So the closeness of measured to the actual, that is called accuracy. For example, if the actual length of a rod is 10 centimeter, a student comes and he determined the length by meter rod and he found the reading as 9.1 centimeter. Another student comes and he determined the length as 9.5 centimeter. Another student comes and he measured the length by meter rod and found as 9.7 centimeter. Okay, these are the 3 readings measured by different students. Okay, now we are studying that accuracy about this reading. Okay, we are studying accuracy of this reading. Okay, what is meant by accuracy? Accuracy means the closeness of measured value to the actual value. Okay, this is the actual value, this is the actual value, and these are the measured values. Okay, the actual value and the measured value should close to one another. So look at here, this measured value, look at this measured value, and look at this measured value. So tell me which measured value is more close to actual value. Of course the answer is 9.7. 9.7 centimeter is more close to the actual value. So it means that 9.7 is more accurate. 9.7 is more accurate. So a reading, a measured value which is more close to the actual, that will be more accurate. So 9.7 centimeter is more accurate to the actual value. Okay, so this is more accuracy. Okay, now if I want to find the error amongst these measured values, so error is defined as the difference between actual value and measured value is called error. Okay, so look at here, look at the actual value. Actual value is 10 centimeter. Yes, 10 centimeter. What is the first measured value? First measured value is 9.7. Yes, first measured value is 9.7. Okay, so what is the error? The error is 0.9 centimeter. Okay, now look at the error in the second reading. Look at the error in the second reading. Second reading is 9.7, 9.5. Okay, the actual value is 10 centimeter. The second measured value is 9.5 centimeter. So the error is 0.5 centimeter. Okay, now we found we want to find the third error. So actual value is 10 centimeter, the third measured value is 9.7 centimeter, so the error is 0.3 centimeter. Okay, so these are the errors. These are the errors in the measured values. So now look at the magnitude of error. Look at the magnitude of error. We know that accuracy depends on the magnitude of error. Accuracy depends on the magnitude of error. It means that accuracy and the magnitude of error are inversely proportional to one another. So if the magnitude of error is small, it means that accuracy is large. So look, this error is much smaller. This error is very small as compared to these errors. If we compare these errors, so we will found that 0.3 centimeter is smaller than 0.9 and 0.5. So it means that if this error is smaller, so it will be more accurate. So it means that 9.7 is more accurate because of two reasons. The reason number one is 9.7 is more close to the actual, and another reason is 9.7 has a smaller error. If it has a smaller error, it means that it is more accurate. So accuracy is inversely proportional to error, magnitude of error. Okay, remember another one error is called the relative error. The relative error. Okay, relative error is equal to least count divided by measured value. In federal board books, we call this error as fractional uncertainty. Okay, in Peshawar board it is called relative error, while in federal board it is called fractional error, fractional uncertainty. So fractional uncertainty is equal to least count by measured value. Both are same errors. There is no difference between them, but in federal board it is called fractional uncertainty, in Peshawar board it is called relative error. Okay. Now if we convert this error into percentage, so it will be relative percentage error. Relative percentage error is equal to least count by measured value multiplied by 100%. Okay, so this is called relative percentage error. Why we are going to study errors and percentage error? Because we are dealing with the accuracy. It means that the magnitude of error or the percentage error is smaller, the reading will be more accurate. Okay, so for the accuracy purpose, we have to study the errors. We have to study the magnitude of error. So it means that the magnitude of error are very important to the physics, because physics is the study of accurate measurements. Physics is study of accurate measurements. Okay. For accuracy purpose, we have to study the errors, we have to minimize the error, we have to vanish the errors. Okay. For example, if the MCQs come in M decade, national M decade, for example, a 10 millimeter length is measured by meter rod, then its percentage error is 1%, 0.1%, 10%, or 100%. Okay. If the MCQs come like this, that 10 millimeter of length is measured by meter rod, then what is the percentage error? Okay. So we have to find out the percentage relative error. But remember, we should know about the least count. So tell me, what is the least count of meter rod? We know that. The least count of the meter rod is 0.1 centimeter. Okay. The least count of the meter rod is 0.1 centimeter. So remember, we have to look to the unit of the measured value. The unit of the least count and the unit of the measured value should be same. Why it should be same? Because if the unit of the least count and measured value are same, so they will be cancel one another, because relative error has no unit. Relative error is unitless. So for a unitless quantity, it means that the ratio will have the same units to cancel out, which and the quantity should have no unit. Okay, so if the measured value is given in the millimeter, so least count should be in the millimeter. Remember that. So here the measured value is given in the millimeter, 10 millimeter, so it means that least count must be in millimeter. So what is the least count in millimeter of meter rod? That is 1 millimeter. Okay, the least count of the meter rod in millimeter is 1 millimeter. Okay, putting the values here. So the least count is 1 millimeter. Yes, we know that the least count of the meter rod, and the measured value is 10 millimeter. Yes, multiplied by 100%. Okay, so millimeter cancelled out. Yes, they are cancelled out. So, and 10 multiplied 10 at 100, so it is 10%. Okay, so relative percentage is 10%. Okay, so why the unit should be same? Because same units will be cancelled out and relative error will have no unit. Okay, this is all about accuracy. Now come towards uncertainty. Okay, the maximum possible estimate of error is called uncertainty. The maximum possible estimate of error is called uncertainty. Okay, so what is meant by uncertainty? It is the maximum possible error. It is the maximum possible error. Okay, so it means that each and every error is not uncertainty. That error will be uncertainty which has a maximum value. So if any device have the maximum possible value of error, so that will be called the uncertainty. So it means that uncertainty is called the range of error. Uncertainty is called the range of error. Okay, what is meant by uncertainty? Uncertainty means uncertain. Uncertain means which is not exact. Which is not exact. That is called uncertain. Okay, which is not sure. Let us take an example. If I ask what is the population of Pakistan and someone say that it is exactly 25 crore, is it correct? The answer is no. It is not 25 crore exactly. Maybe it is 25 crore plus minus 1 crore plus minus 1 crore, means it may be 26 crore, it may be 24 crore. So it means that the population of the Pakistan is not exactly 25 crore. So it may be plus 1 means it will be more than 1. 25 plus 1. So it may be 26 crore, and 25 minus 1, it may be 24 crore. It means that the population is in between 24 crore and 26 crore. Okay. So it means that this is the uncertainty in the population of Pakistan. So one is called the uncertainty. Uncertainty means which is not exact, which is not sure. So we are not sure about 25 crore. So we will say that maybe the population of Pakistan is 24 crore or 26 crore. Okay. So uncertainty means which is not sure, which is not exact, which talk about approximation. Okay. So there are two types of uncertainties. There are two types of uncertainties. One is called the relative uncertainty. One is called the relative uncertainty, and the relative uncertainty is equal to half of the least count. And the other is called absolute uncertainty, which is equal to least count. Okay. So that is the relative uncertainty. That is the types of uncertainty. If we talk about the relative uncertainty in meter rod, suppose let us take an example of meter rod. So if I want to find the relative uncertainty in the meter rod, so look at here, putting the value of least count here. So what is the least count of the meter rod? 0.1. Yes, centimeter divided by 2. So it will be 0.05 centimeter. So this is the relative uncertainty in meter rod. What does it mean? It means that the maximum error in meter rod is possible, that is 0.05 centimeter. Okay. Now, if we talk about the absolute uncertainty, so putting the value of least count, that is 0.1 centimeter. Okay, so the total error in the meter rod may be 0.1, not more than 0.1, not more than 0.1. It may be equal to 0.1 or less than 0.1. So the maximum possible error in the meter rod is possible, that is 0.1 centimeter. Okay, so that is the meaning of uncertainty. Uncertainty means which is not sure, which is not exact, which talk about the approximation. So how to deal with the uncertainty and how to indicate the uncertainty. So remember, uncertainty is indicated by plus minus. Suppose the length is given 1.5 plus minus 0.1 centimeter. So this plus means this 1.5 is maybe 0.1 more. Minus means this 1.5 may be 0.1 less. So this 1.5 centimeter will maybe 0.1 more and maybe 0.1 less. So it means that 1.5 is the minimum range of 1.5 is 1.4 and the maximum range of 1.5 is 1.6. So this is the range of error. Okay, this is the indication of error. So how we can indicate the uncertainties? By a plus minus. Okay, now come towards the rules of uncertainty. What is the rules of uncertainties? Okay, suppose we talk about addition and subtraction. Addition and subtraction have the same rule for the total uncertainty. For example, if we say that distance S1 is equal to 2.5 plus minus 0.1 centimeter, distance S2 is 1.8 plus minus 0.2 centimeter. Okay, these are the distances given with uncertainties, and we want to add these distances. And we want to find the total uncertainty in the addition. So how we can find the total uncertainty? Remember, the rule for the total uncertainty is summation of least counts or summation of absolute uncertainties. Okay, so these are the measured values. Look, these are the measured values, and this is the uncertainty, or this is the least count. These are the least counts. So what is the rule for the total uncertainty? Summation of least counts. So least count in first quantity plus least count in second quantity plus least count in third quantity plus least count in fourth quantity, and so on. So here we have two quantities. So least count of first quantity plus least count of second quantity. Okay, so what is the least count of first quantity? That is 0.1, and least count of second quantity is 0.2. So the total uncertainty will be 0.3 centimeter. 0.3 centimeter is the total uncertainty in meter rule of addition. Okay, now we talk about subtraction. Okay, for example, if one displacement is 1.5 centimeter plus minus 0.1 centimeter towards east, another displacement is 1.4 centimeter plus minus 0.3 centimeter towards west. This displacement is towards east, this displacement is towards west. So we want to find the net displacement, which is equal to d1 minus d2. Okay, so if vectors are opposite, so we have to subtract these vectors. Okay, so we have to find the total uncertainty in the subtraction, in the net displacement. Okay, so for the total uncertainty, rule is same, the summation of least count. Okay, so rule for addition and rule for subtraction is same for the total uncertainty. The rule of total uncertainty in case of addition and subtraction are same. Okay, what is summation? What is meant by summation? Summation means least count in first quantity plus least count in second quantity. So what is the least count of first quantity? That is 0.1. Okay, what is the least count of second quantity? That is 0.3. So the total uncertainty is 0.4 centimeter. So that is the total uncertainty in case of subtraction. Okay, So these are the rules about addition and subtraction. Okay. The second rule is we have to multiply two numbers, two quantities, or divide the two quantities. Okay. So for example, length is given 15.6 plus minus 0.1 centimeter, and the width is given 10.80 plus minus 0.01 centimeter. Okay, this is the width, and we have to find the total uncertainty in the area. So first tell me, what is the formula for the area? That is equal to length cross width. That is the formula for the area. So in the formula, length and width are multiplied. It means that we are studying multiplication rule. Because length and width are multiplied to one another. Okay. So what is the rule for multiplication? For total uncertainty. So let's have a look. Total uncertainty in case of multiplication is summation of percentage errors. That is the rule for multiplication and division. What is meant by summation? Summation means percentage error in one quantity plus percentage error in another quantity. Okay. So first we have to find the percentage error in length, then we have to find the percentage error in width, then we have to add these percentage error, so we will get total uncertainty in the area. Okay. So first we are going to find the percentage error in length. So what is the formula for the percentage error? We know that least count divided by measured value multiplied by 100%. That is the formula for the percentage errors. Okay. So what is the least count for the length? That is 0.1. Yes. What is the measured value? 15.6. So putting the values here. So 0.1 divided by 15.6 multiplied by 100%. Okay. So if you calculate this by calculator, so you will get 0.64% is the percentage error in length. So tell me, this answer is precise or accurate? This is not in our topic, but I'm going to ask for your information. So tell me, this answer is precise or accurate? So the answer is, this answer is precise, not accurate. According to the previous topic, which was significant figure. In significant figure, we say that the answer will be as least significant as least in the individual figure. So look at here. Here, this least individual figure have one significant figure, so the answer should have one significant figure. So it means that the answer should be 0.6%, which will be the accurate answer. So it means that this answer is precise but not accurate. Okay. So this was for your information. That was unnecessary. So let us now, we have to find the percentage error in width. What is the formula for the percentage error in width? Least count by measured value multiplied by 100%. Okay. That is the formula for the relative percentage error. So what is the least count of width? That is 0.01. What is the measured value? 10.80. So putting the value here, so it will be 0.01, 10.80 plus multiplied by 100%. So we will get 0.091%. So that is the percentage error in width. Now putting the value in total uncertainty. So what is the percentage error in length? That is 0.64% plus what is the percentage error in width? That is 0.091%. So it will be 0.73%. That is the total uncertainty in case of multiplication. Okay. So that is the total uncertainty in case of multiplication. Now come towards division rule. Okay. This was all about multiplication. Now come towards division rule. For example, the current is given 2.73 plus minus 0.05 ampere. The voltage is given For example, अच्छा, तो वोल्टेज इक्वल है 7.3 प्लस माइनस 0.1 volts. Okay, the current is given, the voltage is given, and these current and voltage have some uncertainties. The uncertainty of the current is 0.05 and the uncertainty of the voltage is 0.1 volts. Okay, we have to find the uncertainty in the resistance. So what is the formula for the resistance? According to Ohm's law, R is equal to V by I. So it means that voltage and current are divided in the division form. So it means that we have to use the division rule. So this is division rule. Okay. So what is the total uncertainty in case of division? The total uncertainty in case of division is summation of percentage errors. Summation of percentage errors. Okay. So it means that the rule for multiplication and division is same. The rule for total uncertainty in case of multiplication and division is same. Okay, what is meant by summation? Summation means percentage error in one quantity plus percentage error in another quantity. Okay, so first we have to find the percentage error in voltage, then we have to find the percentage error in current, then we have to add them, so we will get the total uncertainty in the resistance. Okay, first we have to find the percentage error in voltage. What is the formula? Tell me, what is the formula? Yes, that is least count by measured value multiplied by 100%. Okay, what is the least count of voltage? That is 0.1, and the measured value is 7.3 plus multiplied by 100%. So we will get 1.3%. Okay, that is the percentage error in voltage. Now we have to find the percentage error in current. So the formula for the percentage error in current is least count divided by measured value multiplied by 100%. Okay, so what is the least count for the current? That is 0.05 and the measured value is 2.73. Okay, so percentage relative error in current is equal to, what is the least count? 0.05 and the measured value is 2.73 multiplied by 100%. Okay, so it is 1.8%. So this is the percentage error in current. Okay, so the total uncertainty is equal to percentage error in voltage plus percentage error in current. What is the percentage error in voltage? That is 1.3. Okay, 1.3%. Okay, what is the percentage error in current? That is 1.8%. So putting here 1.8%. So the total error is 3.1%. That is the total uncertainty in the resistance. Okay, this is all about multiplication and division rule. Now come towards the third rule, that is power rule, and the last rule. The last rule is power rule. Okay, for example, if we have a radius of the sphere 2.5 plus minus 0.1 centimeter, and we have to find the uncertainty in volume of the sphere. We have to find the total uncertainty in volume of the sphere. Okay, so what is the formula for the volume of the sphere? That is 4 by 3 pi r cube. 4 by 3 pi r cube. Okay, so look at here. Radius has a power, so we have to use the power rule because there is a power on the radius, so we have to use the power rule. Okay, so what is the total uncertainty for the power rule? Look at the rule. The rule is power multiplied by percentage error. Okay, so what is the power of radius? That is 3. We know that. So first we have to find the percentage error in the radius, then we will put in the total uncertainty. Okay, so we want to find the total uncertainty in volume of the sphere. Okay, so first we have to find the percentage error in radius. So formula is least count divided by measured value multiplied by 100%. Okay. What is the least count? The least count is 0.1 centimeter. What is the measured value? That is 2.5 multiplied by 100%. Okay. So the answer is 4%. 4% is the percentage error in radius. Okay. That is the percentage error in radius. So putting these values in the total uncertainty, that is power multiplied by percentage error. Okay. What is the power? The power on the radius is 3. Okay. What is the percentage error? That is 4%. So the total uncertainty is 12%. Okay. So this is the total uncertainty in case of power rule. Okay. So we studied 3 rules for the total uncertainty: addition and subtraction, multiplication and division, and the power rule. Okay. Inshallah, you would understand it, and there will be no problem. If there is any problem, you can ask. You can ask in physical classes also. Okay. So now another topic is dimensions. Dimension is the last topic of this chapter. Okay. Dimension, how we can define it? The process in which we represent or we express other quantities into base physical quantities. Is called dimensions, in which we represent other quantities into the base physical quantities is called dimension. Okay. So base quantities are, we know that their units, and we are studying their dimension. Okay. First base quantity is length, its unit is meter, its dimension is L square bracket. Okay. Another is mass, its unit is kilogram, its dimension is M square bracket. Okay. Another is time, its unit is second, its dimension is T square bracket. Another is temperature, temperature has unit of Kelvin and its dimension is K square bracket. Okay. Another is electric current, electric current has unit of ampere, its dimension is A square bracket. Okay. Another is amount of substance, amount of substance has a unit of mole is a unit of mole, its dimension is N square bracket. Okay. Another is luminous intensity, luminous intensity is candela, its dimension is I square bracket. Okay. So these are the dimension of base quantities. You have to memorize it. You have to memorize it, that what is the dimension of length, mass, time, temperature, and so on. Okay. So now let us take an example. Okay. The definition of speed is distance per time. That is the definition of speed. What is the unit of distance? The distance has unit of meter and the time has second. Okay. The unit of distance is meter, the unit of time is second. What is the dimension of meter? Look at here. What is the dimension of meter? That is length, L square bracket. Okay. L square bracket is the dimension of meter. What is the dimension of second? The dimension of second is T square bracket. So it is T square bracket. Okay. Shift T to the numerator. So its power will be negative. So if we shift this T to the numerator, so its power will be negative. Okay, so write it in the one square bracket, so it will be LT minus 1. Okay, so tell me, what is length? It is base. What is time? It is base. What is speed? It is derived. It means that we represent a derived quantity into a base quantity. That is called dimensions. So dimension means when other quantities are expressed in the base physical quantities. That is called dimension. When other quantities are expressed in the base physical quantities called dimension. So length and time are base, speed is derived, so we express the derived quantity into the base, that is called dimension. Okay, that is the definition of dimension. Let us take another example. Another example is density. Okay, the equation for the density is mass per unit volume. What is the unit of mass? That is kilogram. What is the unit of volume? That is meter cube. Okay, what is the dimension of kilogram? That is m square bracket. Yes. What is the dimension of meter? Dimension of meter is L square bracket. Okay, so L square bracket, but the power of the meter is cube, so it will be L cube. Okay, if we shift this denominator to numerator, so its power will be negative, so its power is minus 3, and write it down in the one square bracket, so it will be ml minus 3. That is the dimension of density. So what is density? Density is a derived quantity, and mass and length are the base quantities. So we express a derived quantity into the base quantity, so that is called dimensions. Okay, that is the definition of dimension. Inshallah you will understand it. Okay, now we are studying the features of dimensions. The features of dimensions. Okay, the first thing is dimensional constants. Dimensional constants. Okay, dimensional constants are those which has dimension, means their dimensions exist. Their dimension exists, but their values are constant everywhere in the universe. Their values are constant everywhere in the universe. That is called dimensional constant. Okay. Let us talk about gravitational constant. The value of gravitational constant is 6.67 10 power minus 11 Newton meter square per kg square. Okay, so this value is same on the earth, this value is same on the moon, this value is same on the sun. So this value is same everywhere in the universe, and this G has dimensions. So if the dimensions are there and its value is constant, so gravitational constant is called dimensional constant. Okay, let us take an example. Rydberg constant. The value of Rydberg constant is 1.097 in 10 power 7 per meter. Okay, so the dimension of Rydberg constant is exist. It means dimension is there, and its value is constant everywhere. So Rydberg constant is dimensional constant. Okay, now talk about Planck's constant. The value of Planck's is 6.6 in 10 power minus 34 joule second. Okay, so the value of Planck's constant is constant everywhere, and dimension exists, so it means that it is called dimensional constant. Okay, another feature is dimensional variables. Dimensional variable. Okay, dimensional variable are those which has dimensions, means dimension exists, but their values are changing. Their values are changing. For example, my weight on the earth is 1000 Newton. My weight my weight in the space is 0. So the values of my weight is changing. The value of g on the earth is 9.8 meter per second square. The value of g on the moon is 1.6 meter per second square. So the value of g is changing point to point. So it means that when the quantity, the value of the magnitude or the quantity is changing and it has dimensions are there. So this quantity is called dimensional variable. So each and every quantity, that is force, torque, power, energy, acceleration, etc., these are our dimensional variables. Okay, these are our dimension variables. Okay. The third one is dimensionless constants. Dimensionless constant. Dimensionless means dimensions are not exist. Dimensions not exist. Okay, dimension not exist, but their values are constants. Dimension is not exist, but their values are constant. So that is called dimensional constant. For example, pi. The value of the pi is 3.14. It is constant everywhere. It is constant everywhere. Okay. But pi has no dimension. For example, iota. Iota, the value of iota is -1 under root. Its value is constant everywhere, but it is dimensionless. Suppose 1, 2, 3, etc., 4 by 5, 5 by 4, 11 by 21, etc. So these are the constant numbers. So these constant number has no dimensions. These constant number have no dimensions and their values are constants. So these are called dimensionless constant. Okay. The last one is dimensionless variables. Okay. Dimensionless mean dimension is not exist. Okay. Dimensions is not exist and their values are changing. Their values are changing. Okay. For example, refractive index. The value of refractiveness for air is 1. The value of refractive index is for water is 1.33. The value of refractive index for glass is 1.55. So look at here. The value of the refractive index is changing when the medium is changed. So it means that the value is changing and it has no dimension. So it is called dimensionless variable. Okay. For example, relative permittivity. Relative permittivity for air is 1. For example, relative permittivity for the water is 80. For example, relative permittivity for the conductor is infinite. So it means that the value of the permittivity is changing and it has no dimensions. So that is called dimensionless variables. Okay. For example, if we talk about the strain, okay. For example, if we talk about another thing, that is plane angle. For example, if you talk about the solid angle, for example, if you talk about etc. So these are called dimensionless variables. Okay.